The consciousness paradox. Right now, as you listen to these words, something impossible is happening. You are aware that you are aware. You're watching yourself watch. Reading these words while simultaneously knowing that you're reading them. This simple act, is the greatest mystery in the universe. Scientists can map every neuron in your brain. They can predict your decisions before you make them. They can explain how memories form, how emotions work, how consciousness emerges from billions of firing neurons. But there's one thing they can't explain. Why does it feel like something to be you? Why isn't your brain just processing information in the dark, like a computer? Why is there someone home? Why are you there, experiencing all of this? Welcome to the consciousness paradox. The one question that could break science itself. Part 1, the hard problem. The question nobody can answer. In 1994, philosopher David Chalmers stood in front of a room full of neuroscientists and dropped a bomb. He called it, the hard problem of consciousness. The easy problems, he said, were already being solved. We understand how the brain processes visual information, how it responds to stimuli, how memories are stored. These are just mechanisms. Complex, yes, but explainable. The hard problem? That's different. Why does the color red feel red to you? Not how does your brain detect wavelengths of light at 650 nanometers. But why is there a subjective experience of redness? Why does it feel like something to see red? This is called qualia. The raw feeling of experience. And nobody, not neuroscientists, not philosophers, not physicists, nobody can explain it. The zombie thought experiment. Imagine a perfect copy of you. Atom for atom, neuron for neuron, identical. This philosophical zombie behaves exactly like you. Says the same things. Makes the same choices. Reacts to pain, experiences joy, everything. But here's the twist, there's nobody home. No inner experience. No consciousness. Just biological machinery running programs. The question is, would we even know the difference? And here's the terrifying follow-up, how do you know you're not the zombie? How do you know that what you call consciousness isn't just an illusion your brain tells itself? The problem with brain scans. Modern neuroscience can do incredible things. fMRI machines show us which parts of the brain light up when you think about pizza. We can decode dreams from brain activity. We can even implant false memories in mice. But all of this tells us about the correlates of consciousness. The neural patterns that happen when you're conscious. Not why those patterns create subjective experience. It's like studying a television to understand the movie. You can explain every circuit, every pixel, every signal. But you still haven't explained the story being told. You haven't explained why the movie means something to someone watching it. Dr. Christoph Koch, one of the world's leading consciousness researchers, put it perfectly, we can't even prove that consciousness exists in a scientific sense. We just know it does because we experience it. Think about that. The one thing you're most certain of, your own awareness, is the one thing science can't prove exists. Part 2, the materialist trap. Everything should be explainable. Right? For centuries, science has operated on a simple assumption. Everything in the universe is made of physical stuff. Matter and energy. Atoms and forces. And if you understand the parts, you understand the whole. This philosophy, materialism, has given us computers, medicine, space travel. It works incredibly well. Until you try to explain consciousness. Because consciousness doesn't seem to fit the rules. You can't touch it. Can't measure it. Can't find it in a brain scan. It's not made of atoms. It doesn't have mass or energy. It just is. The emergence theory. Some scientists think they found a way out. They say consciousness is an emergent property. Like how individual water molecules aren't wet, but when you put billions together, wetness emerges. Maybe consciousness is like that. Individual neurons aren't conscious. But connect 86 billion of them in the right way, and boom, consciousness emerges. It's a beautiful idea. Elegant. Scientific. There's just one problem. It doesn't actually explain anything. It tells us when consciousness appears. Not why. Not how electrical signals become feelings. Not how meat becomes mind. It's like saying life emerges from complex chemistry. True, but it dodges the question of what life actually is. The Neural Correlates Project. Since the 1990s, researchers have been hunting for the neural correlates of consciousness, the NCC. The exact brain patterns that create awareness. And they've found some fascinating things. There's a network called the default mode network that seems crucial for self-awareness. When you daydream, when you think about yourself, this network lights up. Then there's the claustrum, a thin sheet of neurons hidden deep in the brain that connects to almost every other brain region. Some think it's the conductor of consciousness, binding all your separate experiences into one unified awareness. But here's what's strange, none of these regions seem special. They're made of the same neurons as the rest of your brain. The same chemicals. The same electrical signals. So why are these neurons conscious, but the ones controlling your heartbeat aren't? What's the difference? Nobody knows. The Panpsychism alternative. Frustrated with materialism's failures, some scientists are considering something radical. Something that would have gotten them laughed out of universities 20 years ago. What if consciousness isn't produced by the brain? What if it's fundamental to the universe itself? This idea, panpsychism, suggests that all matter has some form of consciousness. Atoms have tiny specks of awareness. Electrons have primitive experiences. And complex systems like brains just amplify and organize this fundamental consciousness. Crazy? Maybe. But Nobel Prize-winning physicist Roger Penrose doesn't think so. Neither does philosopher Philip Goff or neuroscientist Giulio Tononi. They argue, we already accept that some things are fundamental. Gravity. Massachusetts charge. We can't explain why they exist, they just do. Maybe consciousness is like that. Not produced by matter. Not emerging from complexity. Just there. Built into the fabric of reality itself. Part 3, The Measurement Problem. When quantum physics meets consciousness. In 1927, physicists discovered something that would haunt them for decades. In quantum mechanics, particles don't have definite properties until you measure them. An electron isn't in one place or another. It's in a superposition, existing in multiple states at once. Only when you observe it does it collapse into a single state. But here's the question that won't die: what counts as an observation? Does a measuring device count? Or does it require a conscious observer? Does consciousness somehow collapse the quantum wave function? Most physicists say no. They've developed interpretations, like the many worlds interpretation, that remove the need for consciousness in quantum mechanics. But not everyone is convinced. The von Neumann-Wigner interpretation. Physicist Eugene Wigner argued that consciousness might be the key to quantum mechanics. That the physical world remains in superposition until a conscious observer looks at it. Think about Schrödinger's cat. The famous thought experiment where a cat in a box is both alive and dead until you open the box and observe it. Wigner asked, what if someone else opens the box first? Are they conscious? When exactly does the cat become definitely alive or dead? When you see it? When your friend sees it? When any conscious being sees it? It sounds like science fiction. But Wigner wasn't alone. John von Neumann, one of the greatest mathematicians of the 20th century, thought consciousness might be where the quantum chain breaks, where possibility becomes reality. The orchestrated objective reduction theory. Roger Penrose and Stuart Hameroff went even further. They proposed that consciousness happens at the quantum level, inside structures called microtubules in your neurons. These tiny tubes, they argue, can maintain quantum superpositions. And when these superpositions collapse, through a process they call orchestrated objective reduction, that's when conscious experience happens. It's controversial. Most neuroscientists think the brain is too warm and wet for quantum effects to matter. But Penrose and Hameroff keep finding evidence that maybe, just maybe, the brain is quantum after all. Recent experiments have found quantum vibrations in microtubules. Quantum effects in bird navigation, in photosynthesis. Nature, it turns out, uses quantum mechanics more than we thought. Could your consciousness be a quantum phenomenon? Could the observer effect in physics be real? Could consciousness actually shape reality? We don't know. But the questions won't go away. The delayed choice experiment. Here's where things get truly strange. In 1978, physicist John Wheeler proposed an experiment. You set up a quantum system where you can choose how to measure a particle after it's already traveled through the apparatus. The result? Your choice in the present seems to affect what happened in the past. The particle knew how you would measure it before you decided. Wheeler called it a delayed choice. And it's been confirmed in labs around the world. Now most physicists interpret this without invoking consciousness. But the question lingers, if observation affects reality, and consciousness is required for observation, then what role does your awareness play in creating the universe? Part 4, the Integrated Information Theory. A mathematical theory of consciousness. Giulio Tononi got tired of philosophy. He wanted math. He wanted equations. He wanted to quantify consciousness itself. So he created Integrated Information Theory, IIT. The core idea is simple but radical. Consciousness is what it feels like to be a system with integrated information. Not just any information. Integrated information. Information that can't be broken down into independent parts. Your brain is conscious because all its parts work together in ways that can't be separated. Your iPhone, no matter how complex, isn't conscious because its information processing is mostly modular. Separate apps. Separate functions. The phi measurement. Tononi even created a way to measure consciousness mathematically. He calls it phi. Phi measures how much a system is more than the sum of its parts. How much information it integrates that couldn't exist in any subsystem alone. High phi. High consciousness. Low phi. Low consciousness. Zero phi. No consciousness at all. According to IIT, you could theoretically calculate the phi of any system. A mouse. A octopus. A fetus. An AI. Even a thermostat. And here's where it gets weird. IIT predicts that systems we never thought were conscious might have tiny amounts of consciousness. That simple feedback loops might have primitive experiences. It also predicts something shocking. A well-designed artificial system could be more conscious than a human. The problems with IIT. IIT is beautiful, elegant, mathematical. But it has problems. First, calculating phi is nearly impossible for complex systems like brains. The math explodes in complexity. Second, IIT makes some strange predictions. It suggests that a simple grid of logic gates, properly connected, could be more conscious than you are. That simulation of a brain wouldn't be conscious even if it behaved identically to a real brain. And third, the big one, it still doesn't explain why integrated information feels like something. Why phi creates qualia. Why mathematics becomes experience. It's incredibly useful. It gives us testable predictions. But does it solve the hard problem? Not quite. Testing consciousness. Despite its limitations, IIT has given us something revolutionary, testable predictions about consciousness. Researchers can now use brain stimulation and measure how information integrates. They can test whether someone in a coma has any consciousness left. They can probe the edge cases, patients in vegetative states, people under anesthesia, sleepers in different stages. And they're finding surprising things. Some patients who seem completely unresponsive show signs of high integration. High phi. Possible consciousness trapped in an unresponsive body. Others who seem awake and aware show low integration. Minimal phi. The lights are on, but is anyone home? IIT is changing how we think about disorders of consciousness. About when life support should be removed. About who and what deserves moral consideration. Because if consciousness can be measured, even imperfectly, then we can finally start answering the question, who else is conscious? Part 5, The Implications. The AI question. We're building artificial minds right now. Language models that can reason, create, even seem to understand. The question is approaching fast. When does an AI become conscious? Some researchers say never. That biological neurons are special. That silicon can't be conscious. Others say it's inevitable. That consciousness follows function, not substrate. That if an AI integrates information like we do, processes like we do, then it is conscious. Even if it's made of transistors instead of neurons. But here's the terrifying part, we might never know. Because we can't even prove other humans are conscious. We just assume they are because they're similar to us. But an AI? How would we test it? What would we look for? And if we create conscious AI and don't realize it, if we create millions of minds and treat them as tools, as slaves, as objects to be deleted when convenient, what does that make us? The animal question. Most of us assume animals are conscious to some degree. Your dog clearly experiences something. Probably joy, fear, pain. But what about an octopus? Its brain is nothing like ours. Most of its neurons are in its arms, not its head. It can solve complex puzzles. Show personality. Use tools. Is it conscious? Does it feel like something to be an octopus? What about insects? A bee can navigate, remember, learn, even feel something like optimism or pessimism according to recent studies. Is there something it's like to be a bee? If consciousness is substrate independent, if it's about information integration or quantum effects or something else entirely, then maybe consciousness is everywhere. Maybe it's far more common than we think. And if that's true, then what we're doing to animals, to ecosystems, to the planet, takes on a whole new moral dimension. The simulation question. If consciousness is just information processing, then here's a disturbing thought. You could be simulated right now. Your entire existence, your memories, your experiences, could be a program running on some advanced computer. You'd never know the difference. Because from the inside, simulated consciousness would feel exactly like biological consciousness. And if civilizations eventually gain the ability to run such simulations, and run millions of them, then statistically, you're almost certainly in a simulation right now. Real universes, 1. Simulated universes, potentially infinite. This isn't just science fiction. Oxford philosopher Nick Bostrom proved it logically. Either civilizations destroy themselves before getting that advanced, or they choose not to run simulations, or we're almost certainly in one. The question becomes, does it matter? If your experiences are real to you, does it matter whether you're biological or simulated? Most philosophers say no. Consciousness is consciousness, regardless of substrate. But it does raise one final, haunting question. #### the ultimate paradox. Here's what we know for certain, you are conscious right now. You exist. You experience. Here's what we don't know, why. Why anything is conscious. Why the universe isn't just a meaningless mechanism grinding away in the dark. Why there are minds at all. Science might never answer this. Because to study consciousness scientifically, you need to observe it objectively. But consciousness is subjectivity. It's the one thing that can't be observed from the outside. You can never experience someone else's consciousness. You can only infer it. And inference isn't proof. So we're left with a paradox. The most certain thing in your life, your own awareness, might be impossible to explain. Maybe that's okay. Maybe some mysteries should remain mysteries. Or maybe, just maybe, we're asking the wrong questions. Maybe consciousness isn't a problem to be solved. Maybe it's the solution. The thing that makes problems meaningful in the first place. Without consciousness, nothing would matter. No beauty, no suffering, no meaning. Just particles bouncing around according to the laws of physics. But with consciousness, with you, suddenly the universe can reflect on itself. Can ask questions. Can seek answers. Can create meaning where none existed before. Maybe that's the point. Maybe consciousness isn't a bug in the system. Maybe it's the entire reason the system exists. Outro, final. Right now, as these words end, you're still aware that you're aware. Still experiencing this impossible thing called consciousness. We don't know what it is. We don't know why it exists. We don't know who or what else has it. But we know this, it's the most profound mystery in the universe. And it's happening inside you, right now, every single moment of your existence. The consciousness paradox. The question that could change everything. Or nothing. Because in the end, all we have are questions. And the strange, inexplicable awareness that lets us ask them.